To identify proportional relationships, we can test rates to determine if they create equivalent ratios. This means that we will write each rate as a ratio, or as a fraction, and simplify them to determine whether they are equivalent. If all ratios are equivalent, then the relationship is proportional. If any of the ratios, even if it's just one, are not equivalent, the relationship is not a proportional relationship. So let's look at some examples. To identify proportional relationships from graphs, we can look at a graph and determine whether or not they create a straight line and pass through the origin. If the graph creates a straight line and it also passes through the origin, then we know that that graph is a proportional relationship. If it does not do both of those things, then our graph will not show a proportional relationship. We can also check for proportionality by checking for equivalent ratios of the x values compared to the y values. This example shows the weight of the Earth compared to the weight of the Moon. This point means that the weight of the Earth is 0 and the weight of the Moon would be 0. So for every 0 pounds on Earth, there's 0 pounds on the Moon. This point represents that for 6 pounds on Earth, something would weigh 1 pound on the Moon. This point means that for every 12 pounds on Earth, something would weigh 2 pounds on the Moon. So we can see here that these points create a straight line. We also can see that that straight line goes through the origin, which is right here at 0, 0. Because both of those are true, I can say that this graph shows a proportional relationship between the weight of objects on the Earth and the weight of objects on the Moon. If we weren't sure, we could always take these in check. So I would start with this point, which has an x value of 6 and a y value of 1, and I would make it into a ratio. Then I would go to my next point, which has an x value of 12 and a y value of 2, and I would write it as a ratio. My next point has an x value of 18 and a y value of 3, so I would write that as a ratio. And my final point has an x value of 30 and a y value of 5, so again, I would write that as a ratio. To determine if this was proportional, I would simplify all of these ratios. 6 over 1 can be simplified by dividing 6 by 1, which gives me 6. 12 over 2, 12 divided by 2 is 6. 18 divided by 3 is 6. And 30 divided by 5 is 6, which means all of these values are equivalent to each other, so that shows that they are changing at the same rate. Because of that, I can say that this is a proportional relationship. Now let's look at this graph. You notice that this graph makes a straight line. However, you can see that it does not pass through the origin, which is down here at 0, 0. So I can say that this is not a proportional relationship. But let's look at why. If I look at the first point on my line, my first point has an x value of 1 and a y value of 20. So I can write that as 1 to 20. My second point has an x value of 2 and a y value of 25. I can write that as 2 to 25. My next point has an x value of 3 and a y value of 30, so I would write 3 to 30. My next point has an x value of 4 and a y value of 35, so that would be 4 to 35. And my final point has an x value of 5 and a y value of 40, so that would be 5 to 40. Now, to check this, I would need to simplify each of these ratios. Well, there's no number that can go into both 1 and 20, so that one is already simplified. There's also no number that will go into both 2 and 25, so that is also simplified. Well, I can see here that my two simplified ratios are not equivalent to each other. So at that point, I know that this is not a proportional relationship. But even if I continue, I can see that none of these are equivalent. 3 and 30 both can be divided by 3. So 3 divided by 30 would give me 1, and 30 divided by 3 would give me 10. You'll notice now I have still no equivalent ratios. 4 and 35 do not have any factors in common, so that fraction is already simplified. 5 and 40 can both be reduced by 5. So 5 divided by 5 would give me 1, and 40 divided by 5 would give me 8. You'll notice that in every one of my simplified ratios, I do not have a single equivalent ratio. Because of this, I know that none of these are proportional, so this graph does not show a proportional relationship between hours and cost. Now let's look at this one. This one shows the relationship between time driving and the distance from home in miles. I can see that this is a straight line, and I can also see that it passes through the origin. Because of that, I know that this is going to be a proportional relationship. I can check by choosing some points on the line. So I know there's a point here, there's a point here. Well, this point has an x value of 2 and a y value of 92. This point has an x value of 6 and a y value of 276. If I chose another point, this point has an x value of 10 and a y value of 46. If I simplified all of these, my first one I can see that both 2 and 92 are divisible by 2. So 2 divided by 2 is 1, and 92 divided by 2 is 46. Then for 6 and 276, I can see that both of those are divisible by 6. 6 divided by 6 is 1, and 276 divided by 6 is 46. For my last point, I can see that both of them are divisible by 10. 10 divided by 10 is 1, and 460 divided by 10 is 46. So you'll notice that when I simplify every ratio of x to y, I have equivalent ratios. So that proves that my line or my relationship is proportional. Now let's look at how we identify proportional relationships from equations. An equation is going to represent a proportional relationship if it is written in the form y equals mx, where m represents the constant of proportionality. The constant of proportionality is also referred to as slope and rate of change. So for this equation, I can see that y is equal to 8 times x. In this equation, I see that 8 is my constant of proportionality, or my slope of my line. Because y is equal to a number times x, and there's nothing being added or subtracted to that, I know that this is going to be a proportional relationship. In this equation, I see y equals 3x minus 4. So for this, I can see that 3 is being multiplied by x, so that would be my slope of my line. But this minus 4 right here means that I am not actually going to be passing through the origin if I put this on a graph. Because of that, this is not a proportional relationship. Next, I have y equals negative 1/2 x. You'll see that I have x being multiplied by negative 1/2, so that is my slope or my constant of proportionality. And I do not have a number being added or subtracted to this, which means that this is a proportional relationship. Now let's look at tables. We can tell if a table represents a proportional relationship if all of the ratios in the table, just like the points on a graph, can simplify to make equivalent ratios. So in this table, I have x values on my top row and y values on my bottom row. To figure out if this makes a proportional relationship, I'm going to write ratios for each of these. So my first ratio would be 1 to 6. My next ratio would be 2 to 12. And my last ratio would be 3 to 18. I need to make sure that these are all in simplest form. Well, I know nothing will go into both 1 and 6, so that is already simplified. But 2 and 12 are both even numbers, so I can divide both by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. 3 and 18 can both be divided by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. You'll notice that when I simplify these, all of these ratios are equivalent. Because of that, I can say that these values create a proportional relationship. Now let's look at another one. This one compares hours to miles. 1 hour traveled 62 miles. In 3 hours, we would travel 192 miles. And in 6 hours, we would travel 366 miles. So we want to know if this makes a proportional relationship. Well, again, we're going to write ratios and determine whether they are equivalent. So my first ratio would be 1 to 62, since that's my first rate. My next would be 3 to 192, since that's my second rate. And my third would be 6 to 366. Now I'm going to simplify if I can. Well, 1 to 62 cannot be simplified, so I'm just going to rewrite it. 3 to 192, I notice, can both be simplified by 3. So 3 divided by 3 is 1, and 192 divided by 3 is 64. Well, at this point, I can see that these ratios are not equivalent, so I know this is not a proportional relationship. But I can finish to see what this one is. I know that both of these can be divided by 6, and 6 divided by 6 is 1. 366 divided by 6 is 61. You'll see that none of these make equivalent ratios, so I know that this is not a proportional relationship.